Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of SolidCAM's multi-sided machining on this machine fixture part. And if you note that this part has to be machined on multiple sides, whether it be the top, the side over here, this side over here. All of these sides must be machined, and this must be done using SolidCAM's multi-axis Indexial machining. Now, if we take a look for a moment at our coordinate system manager, you'll see that we've made different positions for different sides of the part that have to be machined. Now, in our first set of operations, I'd like to do a face mill operations on each one of these sides. So let's first start with the very first operation, and you'll see that I'll be working in Mach 1 position 1. The boundary will be around the stock itself. The face mill that I will be using will be a 100 millimeter diameter face mill. As far as the levels go, I just want to do this with one pass. I don't want to do it in multi-step downs. I'm just going to do this one step down. So I'm leaving this at 0. If I go to my technology, you'll note that I'll be working in the hatch technology. The reason for that is that my part is actually wider than the tool itself. Therefore, the tool cannot do this in one pass. So I'll be using the hatch technology. If we take a look at our simulation, you'll see that the tool will go down across the part in a hatch fashion, clearing all the material that's on top. Now, in our next operation, we'll be doing a face mill again, but this time on this side of the part. So if we were to go into the operation, you'll note that we'll be working on Mach 1 position 2, and the boundary this time will be around this part. The face mill that we'll be using will be the exact same one we've used in our last operation, and in our levels you'll note that we have 2 millimeters of material to remove. Now, in our technology, you'll note the following. We'll be doing this time with one pass, since the tool is actually, in this particular case, wider than the material that has to be taken off from the part. We should look at also one more option over here, is that we have a floor offset. So I'll be leaving 0.2 millimeters off the floor and then doing a finish cut on the part to get a smooth finish. If we're to take a look at the simulation, you'll see that the tool will go down and do that one pass over, and now it's going to go back and do one more pass for the finish cut. Now, the rest of the face mill operations that you see here will be using the exact same technology that we did in Mach 1 position 2 to clear off this side over here, the flip side, as well as this side over here and the bottom over here. Now, in our next operation, I'd like to do a profile operation to clear off this area over here. So if we were to go into the operation itself, you'll see the following. We'll be working in Mach 1 position 1. The geometry in this particular case starts from this line over here all the way to the other side over there. And the end mill that we'll be using will be a 20 millimeter end mill. The levels will be going from our top position up until our profile depth over here. Now, let's go into our technology. In our technology, you'll see that we'll be using a wall offset of 0.3 and a floor offset from the floor. And we'll be doing a step down of every 10 millimeters. Now, since this is a relatively wide area where the end mill that we'll be using cannot cover this entire floor with just a pass over, I'll use the option of clear offset so that we can actually step across the part to get to the actual wall, starting from a clear offset over here and then working its way up until it gets to the actual wall. Now, I'm also be using the option of complete Z level. What that actually does is that it'll first clear off the top the first step, then go back and then clear off the next step up until it gets to the very bottom. If we take a look at our simulation, you'll see that the end mill will go down, do the clear offset, and then when it finishes that step, it'll go to the next step, clearing it off, and then do the final step at the bottom until it gets to the actual wall itself. Now, in our next profile operation, we'll be doing exactly what we did in the previous operation. However, this will just be a finish cut for the floor and the wall. Now, after that, we'll be doing a pocket operation. The area that I'd like to work on now is this area over here. So if I were to go into the operation, you'll see I'll still be working in Mach 1 position 1, and my geometry in this particular case will be this area over here, showing this area as an open pocket. The end mill that I'll be using will be the exact same end mill I used in my previous operation, and my levels, we have our upper level as shown over here, and our lower level will be at the very bottom of the pocket over here. If we go into our technology, if I were to go into the open pocket, you'll see we have the strategy of use profile strategy. So even though this is a pocket operation, since it's open, it can also do a profile strategy just as if it was doing a clear offset. And we'll also have it marked as approach from the outside. If we take a look at our simulation, you'll see that the end mill will actually go down and work on that pocketed area, just like a clear offset, and now it's also doing the finish cut on that floor and wall. Now, in our next operation, we'll be doing a pocket operation, this time on this through pocket over here. So if I were to go into the operation, again, you'll see I'll be working with Mach 1 position 1, and the geometry is this closed pocket over here. The end mill, in this particular case, will be a 12 millimeter end mill, and my levels, as you can see, my upper level being minus 45, this level over here, and the pocket depth will be actually through the part at the bottom over here, and we've also added a delta of minus 1 millimeters, so it actually goes past that edge. We'll also be using a step down of every 6 millimeters. Now you'll note in our technology, since this is not an open pocket, the open pocket option is not available. If we were to take a look at the simulation, you'll see that the tool would actually helical its way through into the part and then finish off the pocket all the way to the very bottom. Next, we've done 3 more pocket operations. The first one being for these 2 areas over here, where we have these edges and these edges marked as open edges. So we're able to use a open pocket strategy for this. Also, we've also done this area over here as an open pocket area, where all these edges over here are marked as open, as well as this. So we'll also do this using that open pocket strategy. And the last operation that we have for the pocket over here is this area over here. Again, this edge marked as an open pocket. Now, in our next operation, we'll be working on the pocket that's on this side. We'll also do an operation on the flip side. And these will both be done using the pocket operation. If I were to go into the first one over here, you'll see that the geometry is on Mach 1 position 2, shown over here, with these edges are marked as open edges. The end mill that we'll be using will be a 20 millimeter end mill, and we can see our levels are going down 5 millimeters. If we were to take a quick look at our simulation, you'll see that we'll be working on that area, and since this is an open pocket, we'll be using the open pocket strategy to clear off that material over here. Now, the same was done in our next operation on the flip side, Again, doing the exact same thing as we can see over here in our toolpath. Now, in our next operation, we'll be working on the same geometry as we did before, but we'll be doing what we call a rest machining. Since our previous end mill was too large to go into these corners, so we've used a smaller end mill to clear out only those corners. And as you can see, we're using the 10 millimeter end mill. If we go into our technology, you can see we've used the option of rest. If I were to go into my rest option, we've also note that I've marked that my previous tool diameter was a 20 millimeter end mill. If we were to take a look at the simulation, you'll see that the end mill will only work in those corners, clearing off only the areas that were not machined before. Now, the same was done in our next operation on the flip side, clearing only the material that was on this side over here. If you take a look at the toolpath, you can see it's only working on those areas. Now, let's start with our drilling operations. We need to drill out on this side all of these holes that we see over here. So first, we'll start with our spot drill. If I were to go in to the first operation, you'll see that we'll be back at Mach 1, position 1, and the geometry in this particular case will start off with these two large holes on top. This spot drill will be a 16 millimeter spot drill, and the levels in this particular case, I'll just be going down a total of 8 millimeters into that hole. If I were to look at the simulation, you'll see that the drill is actually going into those areas using the pecking option for drilling and going down to the defined depth that I gave it. We've also done the same for the next operations, being these holes over here as well as these holes over here. Now, in our next operations, we'll be just doing a regular drilling operation to drill out the holes as shown over here. And if I'll just take a look at the operations itself, for example, we'll take a look at this particular operation over here. You'll see that we'll be using the drill of 17.5 millimeters, and the levels will go all the way down to the bottom using the full diameter of the tool to get to the bottom, plus we've added another 3 millimeters to go past that area. Taking a quick look at the simulation, you'll see that the tool will go into those areas, drilling all the way to the bottom of those holes. Now, the same was done for all of these operations over here, for those holes, and for those holes as well. Now, if we take a look at our last drilling operation, this will actually be the tap for these holes over here. Taking a quick look at the operation, you can see that my geometry are those holes over there, and the tool I'll be using in this particular case will be my M12 tap for those holes. If we go into our technology, you'll note that it's automatically put at the tap cycle. In our next operation, we're just going to do a simple profile operation to mill out this counter bore hole. Taking a quick look at the operation itself, you'll see that the geometry are these circles over here, and the tool that we'll be using will be a 12 millimeter end mill. And if we take a quick look at the simulation, you'll see that the tool will just go directly into that hole and machine out those counter bore holes. Now, to finish off this part, we need to put chamfers on these edges over here to break the sharp edges. So for that, we've done all of these operations to do that for all the different sides. And if we were to go into our first operation, you'll see that my geometry in this particular case are these edges over here, and the end mill that we'll be using will be a 6 millimeter chamfer drill. The levels in this particular case is marked at 0.2 millimeters, as this is the size of the chamfer I'd like to put on those edges. If I were to go into my technology, you'll see we've used the option of chamfer, And in chamfer, we've told it that we're using the cutting diameter of 1 millimeter to work on those edges. Taking a look at the simulation, you'll see that the tool will work exactly on those edges. Now, the same was done for the following edges. This one over here, working on those edges over there. And we've also had it done for these areas as well. The same thing was done for this area, the holes itself, and this area around over here. Now, if we were to go down to this side over here, you'll see that we've also done it for this edge over here, and on the flip side for this edge over here. Going further down, you can see that we flipped it over and done chamfers on these edges, as well for chamfers on the flip side over here on these edges. This actually completed this entire part. If we take a look at the actual simulation on the entire part, you'll see that we've done all of the things on the Indexial machining it in one setup from all sides, including the chamfers at the end, completing this part. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for our Professor tab. Take care and have a nice day.